All right, we're gonna keep going here. This next question should be easier. Okay, next we have an acetic acid. So this is a common name. Remember, some things will have common names that like most scientists use when they're talking about instead of like their IUPAC names. You probably won't run into any, but if you do, there's not many you have to remember. This is one of them though. So we have acetic. Acetic is just ethane or ethane. Yeah, it's ethane or eth. Remember, ethyl is 2 lines. So ethane is 2 carbons. So we have a 2-carbon chain. We have 1, 2. And then the acid tells us this is a carboxylic acid. And remember, carboxylic acid is a doubly bonded oxygen and then bonded to an oxygen and hydrogen, like that. And remember, the carbon that's bonded to the oxygen and the oxygen and the hydrogen, it's always it's the number 1 carbon in the carbon chain. So if this is the first carbon, we have to drag another carbon over here to account for the second carbon in this chain. This is how you draw something like that. Okay, next we have a benzoic acid. So a benzoic acid, the benz tells us that it's a benzene. So first draw a benzene like this. Remember, 6-sided shape, 3 double bonds in it. And then the acid part tells us that there is a carbon going out, and that carbon is doubly bonded to an oxygen, and then bonded to an oxygen and a hydrogen, like that. So that's how you would draw a benzoic acid. Okay, we have a 2-chloroacetic acid. Remember, acetic acid yet again. So we draw 1 carbon, 2 carbon. In the acid part tells us it's a carboxylic acid. So on our first carbon, we doubly bond the oxygen, bond it to oxygen and hydrogen. And then this 2 in chloro tells us on the second carbon, there is a chlorine attached to it. So we go to our second carbon and we attach a chlorine to it, just like that. Okay, here, what kind of organic compound is this? Remember, ketone is just the O. A aldehyde is the O and then an H, but a carboxylic acid is an O and an OH. So that's how you know this is a carboxylic acid, just like that. Okay. Acid catalyzed reaction of an alcohol and a carboxylic acid. So that is here. So whenever you see acid catalyst and a carboxylic acid, we are working with a thing called esterification. So esterification is you take a carboxylic acid and then you add an alcohol to it, and it turns it into an ester. So an ester is a carbon that's doubly bonded to an oxygen, bonded to another oxygen, and then, but on this oxygen that's only singularly bonded, you're gonna add carbons to this. So I'll show you how that looks in a minute. But it's the carbons that are present in this alcohol right here that's being added to the carboxylic acid. But just remember, if you see acid catalyzed and then alcohol and carboxylic acid, you are turning this carboxylic acid into an ester, just like that. So the formation of an ester from a carboxylic acid and alcohol with an acid catalyst is known what kind of reaction? Remember, it's called esterification. Esterification, because we are turning a carboxylic acid with an alcohol, you add alcohol into an ester. So esterification, just remember that. Or you can just remember the Fisher part. Okay, so we have a hydrolysis reaction. So we have benzoate, and 8 is, what are 8s? 8s are the esters. So we look over here, hydrolysis of esters, because 8, that suffix is an ester. So we're reacting with, so whenever you're doing a hydrolysis reaction of an ester, you're going to add water and heat, and it's going to turn into a carboxylic acid. So that's something like this, and an alcohol. So it's something like this. So benzoate ion and ethyl chloride, it can't be that. Benzoic acid, that's the acid, but a methyl chloride, that's an alcohol. And I just don't know what that is. So it's benzoic acid and ethanol. Yes, okay. I'm gonna keep going. The base hydrolysis, this was an acid hydrolysis. Now we're at the base hydrolysis. Of an ethyl propanate, so we're still working with ester, followed by the addition of an acid, produces what 2 organic products? Excuse me. Okay. So this one, the ester is going to turn into a salt, and a salt is always going to be an ion because there's a charge here. Remember, charged things are ions. So remember, if you see salt, think ion, and then plus an alcohol. But if we add an acid here, it's going to turn this salt back into an acid. So again, we're just looking, because that's what the addition of acid. If this wasn't here, we would be looking for an ion and an alcohol. But since we're adding an acid, we're looking for an acid and alcohol. So no one here, that's an acid. That's an acid, but that's not an alcohol. That's an aldehyde and alcohol. It's not looking for that. Here we have an acid and alcohol. So it's going to be D. Okay, keep going, keep going. Okay, here, so this is what esterification looks like. So right here, we have a carboxylic acid. You can tell by the doubly bonded O and then the OH. And we are adding here, you can ignore this bottom part, because in esterification, you're adding heat, and this is the acid catalyst, but you're also adding an alcohol. Remember, alcohol is just OH. So you're going to look for your alcohol in this reaction. Your alcohol is this top one, OH here. And you're going to see what this alcohol, what the carbon is looking like. So our carbon is just a CH3. Remember, just one carbon is a methyl. And in esterification, after this reacts with this, after our carboxylic acid reacts with the alcohol and then the heat, it's going to remove the hydrogen from here, and then whatever the carbon is attached to the alcohol is going to replace the hydrogen. So what that looks like is this. So this carbon right here, it's just one carbon, so it's going to be one line. It's going to replace the hydrogen, and then you're going to add the next line just like that. So if you ever see a carboxylic acid and an alcohol is being added, think of esterification. Okay, we're going to keep going. Yet again, we have esterification here, because you see the alcohol, you see the carboxylic acid. So we're going to take this carboxylic acid. We have 1, 2, 3. So that tells us that this is propyl. because three carbons is propyl. And how you know this isn't isopropyl is isopropyl has one of these H's has no numbers next to it, and these are both 3. Just normal propyl has 2 and 2 and 3. So what we're going to do, we're going to take away this H and then add 3 more lines, just like that. Take away the H, add 1, 2, 3, just like that. So you take away the H and you add these 3 carbons. So 1 carbon, 2 carbon, 3 carbon. And just in case you forgot, every carbon is a dot on this line. So that's a carbon. There's a dot there. There's a dot there, dot there, dot there. That's how you can tell how many carbons there are on a carbon chain. Next. Okay. Now we are getting into amines. So amines come from ammonia. And I don't know if you remember, ammonia is nitrogen and then 3 hydrogens. So here, ammonia, nitrogen, 3 to 3 hydrogens. And we're working with common names here, so we're not going to worry about correctly naming this in just a second. Okay, but here we have the nitrogens, and then we have 3 lines coming off. What does that mean? So remember 1, 2, these double lines like this tells us that these are ethols. Those are all ethols. What that's saying is that there is 3 ethols connected to the nitrogen, and nitrogen is amine. So what we would do, we'd put tri for the 3 of them, ethol, and then just amine, just like that. Remember, if you're looking for common name, you're never going to use like numbers, okay? Just remember that. So here we have the amine, because nitrogen, and then the hydrogen, that's just a part, because that's the hydrogen on the amine. But it's connected to 1, 2, it's connected to an ethol, then also a propyl, 1, 2, 3. So we put the amine down. And remember, always go in alphabetical order when you're putting things before this. So E comes before P, so you're going to put this ethol first, and then the propyl, just like that. Okay. So we're looking here. What is this? What are we looking at? So you're always going to look for key elements when you're looking like in an organic compound. Remember, ketones are just an O. Alcohols are an OH. Aldehydes are an O and an H. Carboxylic acids are an O and an OH. But amines are just a nitrogen bonded to a hydrogen. So this is how you can tell that this is an amine, because you see the nitrogen and you see the hydrogen bonded to it. So just like that, primary amine. Continuing on. So the amine here, amines can be classified in 3 different ways. So it could be a primary amine, which means you're bonded to only 1 carbon. A secondary amine, which means you're bonded to 2 carbons. That's what the R's are. The R's are the carbons. Or a tertiary, which means you're bonded to 3 carbons. So if we look here, it's bonded to 1 carbon, 2 carbons, 3 carbons. That's what tells us this is a tertiary amine, just like that. Okay? Yet again, what kind of amine is this? It's bonded to 1 carbon, 2 carbons. Nope, that's a hydrogen. It's only bonded to 1, 2 carbons. That tells us that this is a secondary. Because remember, if it was just bonded to 1 carbon, it's primary, but it's bonded to 2 carbons, which tells us that it's secondary. Keep her going. Okay, last one for this one. What kind of functional group is this? So we're obviously have an amine, the N and the H. But we're looking if it's primary, secondary, or tertiary. So we look how many carbons is it attached to. It's only attached to one carbon. Remember, one carbon is a primary amine, just like that. Okay, what type of nitrogen functional group is shown in this picture? Yet again, we're working with an amine, the N and the H. How many carbons is it connected to? It's connected to one carbon, two carbons. So this tells us that it's a secondary amine. Just like that. Okay. Last video. I love you. Or I got one more. Love you.